Hey, I'm Charlie Thompson, and welcome to part 2 of the Köppen Climate Classification Lab series. This is Lab 12, and we're going to be dealing with dry climates. So in the notes, I saw a couple of people had said that they were having problems keeping it in their memory, keeping all of the Köppen criteria in their memory. I can't even imagine doing that. So before you start this video, I'm going to recommend that you open up the Köppen Climate Classification sheet that I've given you a link to. The Google Doc, especially for today, the dry, arid, and semi-arid climate portion, step 1, 2, and 3, because that's what this video and this lab is really about. Is it a dry climate or not a dry climate? And on the Köppen Climate Classification sheet, it's a Google Doc. So because it's a Google Doc, you can make your own copy, save it to your directory, and then you can make notes on it. So I would recommend making it yours. Add notes on it. You can change the spacing because it's your document. You can do whatever you want with it. I would, after this video, I would probably write down a bunch of notes for myself, and then I would go through and make changes to this, because you can always go back and get the original and compare it, make sure you didn't mess anything up. But I would make changes so that it's more useful for you. Make it yours. Make it work the way you want this to work. So some review stuff. Köppen system uses 2 or 3 letters. The first letter tells us the general temperature, like A, tropical, E, polar. The second letter tells us about the timing of the rainfall, F for year-round, W, winter dry, S, summer dry, M for monsoon. The third letter tells us more about the temperature during the year. Is the summer unusually hot? Is the winter unusually cold? Remember, the tropical, the A climates, and the E climates don't have seasons, so they don't have a third letter because they don't have seasons. So as you're going through the Köppen climates, remember it's a flow chart, and you have to check them in order. Is it a polar climate? Is every month under 10 Celsius? If it is, it's a polar climate. Let's figure out what it is. If it's not, then you have to check to see, is it a dry climate? Does it meet the criteria for being a dry climate? If it does meet the criteria for being a dry climate, then we got to figure out what kind of dry climate it is. If it's not a dry climate, then you just keep rolling. Is every month over 18? If not, if it is, if every month is over 18, congrats, you found a tropical climate. If not, got to keep looking. Is the warmest month over 10 and the coldest month over freezing? If so, it's a mesothermal. If the coldest month is below freezing, it's a microthermal. If it's not, you did something wrong, go back to the beginning, start over. So, starting off, you check to see, is it a polar climate? If yes, it's a polar climate, then you figure out what it is. If it's not, then you go to the next climate, the dry climates. So here's the way this is going to work. If it's not a polar climate, the next climate type you have to check, dry climate. There's 2 categories for dry climates. There's the steppe, where precip is less than the TH. The TH is the dryness number. We'll spend a lot of time today figuring out how to calculate the dryness number, but if precip is if precip is less than the dryness number, then it's a steppe climate. Steppe is another word for prairie or grassland. Fresno is a steppe climate. So you get enough water to have grasses that will germinate and grow and make seeds and die, but not enough water to have really good tree growth that needs water year-round. So if the precip is less than TH, it's a steppe climate. If precip is less than half of TH. So another way of thinking of this would be to think of TH as a proxy, a stand-in for POTET, potential evapotranspiration. It's not, but it's very similar because the dryness factor is going to be a result. We're going to look at temperature and when it rains to calculate what the TH number is. So yeah, I think you're pretty good. If for the purposes of understanding what the hell's going on, treat the TH number like POTET. It's how much water you need. If you don't have enough water, you're a steppe climate. If you have less than half the water you need, you're a desert climate. If precip is more than TH, then you're not a dry climate, you're a humid climate. And the next climate category to check is A, the tropical climates. So we looked, it's not a polar climate. Now we want to see, is it a dry climate? There's 3 steps, although today I think there might be 4, because step 1, it really has 2 parts. So step 1, calculate how much rain falls in the summer. So we got to figure out when the summertime is, figure out how much rain falls in the summer, and then figure out how much of the annual rain falls in the summer. And then we're going to use that. Once we figure out how much of the rain falls in the summer, we can use that to calculate the threshold number, which is going to tell us how dry the climate is. That's step 1. Step 2, after we have the threshold, we compare the precip, how much rain, to the threshold to determine, is it a humid climate, desert, or steppe? And if it is a dry climate, at this point, then the last thing to do, because when we figure out, is it a dry, we'll figure out at that point, is it desert, steppe, or humid? And if it's desert or steppe, then the last thing to do is figure out, is it an H, hot climate, or K, cold? Again, if you speak German, it helps. Heiß und kalt, hot and cold. The third letter is the average annual temperature, and that involves no math. You'll be happy to hear the last step is the easiest. No math. You just look at the numbers and go, well, is it warmer than 18? It's hot. Colder than 18 year-round? Cold. So those are the 3 steps that we're going to use to determine what kind of dry climate we're looking at. Step 1, calculate how much rain falls in the summer, and then use that to find the threshold number. The threshold number is calculated by doubling the annual average temperature, T, and adding a dryness factor. The dryness factor is determined by how much rain falls in the summertime. April through September are the 6 months that we will use as summer for the northern hemisphere, and October through March is going to be summer for the southern hemisphere. So when we say the summer months, there's 6 months, and they're always going to be the same 6 months. It's either going to be April through September or October through March. If you're in the northern hemisphere, April through September are going to be the summer months. So you should never wonder, what are the summer months? It's either April through September or October through March. And then to determine if you're looking in the northern or southern hemisphere, you just have to compare January, December temperatures with June, July temperatures. Whichever ones are hotter, that's going to be the summer. And if it's April through September is hotter, you're in the northern hemisphere. October through March is hotter, you're in the southern hemisphere. And the reason that that matters is because summer rain is less effective because more evaporates than in winter. So summertime rain, if you think about rain falling on a ground that is hot, more would evaporate. Like I remember moving, I grew up in Southern California, and after it rained, the next day all the puddles were gone. And I remember moving to Northern California and being really perplexed because it rained and then the puddles just stuck around for days because it was warmer. It was warmer in Southern California. It was colder in Northern California. So walking around Chico, realized, hey, these puddles have been here for days. They're not gone. Oh, right, it's colder, so there's less energy to evaporate water. So if the rain falls in the winter, more of it is available for plants. And this is also interesting for those of you that also are in my lecture class. You'll remember the announcement that I posted about rain on the Great Plains. And rain in the plains, turns out it falls mainly at night. So nighttime rain would be more effective than daytime rain in the plain states because it would be cooler. So I haven't seen anybody looking into time of day. For climate classification, we're looking at summer rain versus winter rain, but I think it's going to be interesting, especially if climate change alters the timing of rain during the day, that there'd be regions that are going to get more rain at night that would be more effective. Or there might be regions that get more rain during the day. So, step 1. If the summer precip is more than 2/3 of the total precip, then the TH factor, the dryness factor, is calculated by doubling the annual temperature and adding the number 28. And again, if the climate's in the northern hemisphere, it's April through September is the summer. If the climate station is in the southern hemisphere, and you just look at, when we go through the example, well, you'll see what I'm talking about. You just look at the months and figure out, well, Are October through March the hot ones, or are October through March the cold ones? If the summer precip is between 1/3 and 2/3 of the annual total precip, then the dryness factor is 2T plus 14. And finally, if the rain falls in the winter, the dryness factor is just 2T. So if you have summer rain, you can see the dryness factor is going to be 28 higher, and it's just a number. The TH number, it's just a number. It doesn't represent anything. It's not like centimeters or degrees. It's just a number. But you can see if more rain falls in the winter, it's going to be lower. If the rain falls in the summer, the dryness, the TH factor is going to be higher. So that's step one. Determine the summer precip, and then we can use that to calculate the TH number. Northern, southern hemisphere summers. So step two, once we've calculated the TH number, you compare P to TH. If precip is more than the dryness number, right? If precip is greater than the dryness number, it's not a dry climate, it's a humid climate. You got to go check the next climate group, which is going to be the tropical climates. If P divided by TH is between 0.5 and 1, so precip would be less than TH, but more than half. So if you're getting between half the rain you need and you're still not getting all the rain you need, it's a steppe climate. If when you divide P by TH, it's less than 0.5, that means you're getting less than half the rain you need. The precip would be less than half of potet. So you're a desert. So if P is less than half of TH, it's a desert. Step three, once you've determined what kind of climate it is, it's either a steppe or a desert, then you determine is it a hot or a cold climate. The third letter is the average annual temperature. It's an H if the average temperature is over 18. It's a K if the average annual temperature is below 18. And like I said, at that point, we wouldn't make it to step three. But if at step two, we determined it was a humid climate, then the next climate to check is it a tropical climate? So if it's not a dry climate, then the next thing to do is check to see, is it an A climate? If every month is over 18, it's an A climate, then you got to check to see the timing of the rainfall. Reminder, you got to check climates in this order: the E's, the B's, the A's, the C's, and then the D's, and specifically in this exact order. Just a reminder, super important. Oh, for reasons that you will see shortly. Oh, and a climograph. I forgot to give you examples of climographs. They have a line graph of temperature and a bar graph of rainfall. Climographs are great because at a glance, you can see what the climate's like. Like you can see that it starts to get rainy, and then in the summertime, and you can tell it's the summertime because that's the warmer part of year. You can see there's a dip in precip. You've got an idea of what the average annual temperature is. Also the temperature range, like is there a big difference between summertime and wintertime? So you can see at a glance the timing and amount of the rainfall. You can see the average temperature. You can see the temperature range. Climographs. So Köppen climate symbol, the 2 or 3 letter abbreviation, AF, BWH, CSA, the Köppen climate name, tropical rainforest, hot desert, Mediterranean hot summer. More terms, TH is the dryness threshold number. T is the average annual temperature. P is the total annual precip. The average annual temperature is determined by adding all the months and then divided by 12. The temperature range is the difference between the hottest and coldest months. So let's look at this example climate in Ouagadougou. Here we've got the average annual temperature. That'll be given to you. I'm not going to make you calculate out the annual. I'll make you calculate the range, but not the annual. So the annual average temperature and then the total annual precip. Both of those will always be given to you. So let's use this as an example. The first question I would break out your flow chart and work through this on your own. Is it a polar climate? Is every month below 10? Heck no. In fact, in fact, just looking at the temperatures, it's some sort of tropical climate, right? If we were just looking at the temperatures, it would classify as a tropical climate. Looks like probably some sort of monsoon maybe because of how much rain falls in the summer, and it looks like dry in the winter. But before you can get to the tropical climates, you got to check to see, is it a dry climate? So, step 1, calculate TH. TH is the dryness threshold number. Get it? Threshold. So, find out how much rain falls in the summer. And again, you got to find the summer months. So, is April through September the summer? Or is October through March? So looking at the temperatures, April through September, we've got like 32, 31, 29, and the rest of the year, 24, 27, 30. So it looks like April through September, that's going to be our summer. That's the amount of analysis you have to do. You just look at it and go, well, which 6 months are warmer? Oh, April through September, boom, we're in the Northern Hemisphere. So April through September, those are going to be our summer months. So how much rain falls in the summer? We're just going to add those numbers up, find the summer months, add up the summer rain. So the summer rain added up to 70.3 centimeters. The annual total is 74.3. Summer rain divided by the total gives us the percent as summer rain. This is 95%. So we know that 95% of the rain fell in the summer. So then we have our choice of calculating out the TH. If April through September precip is more than 66, 95 is more than 66, so we're done. TH equals 2T. There is T plus 28. If it wasn't, if this number was between 33% and 66%, then it would be 2T plus 14. And if this number was less than 33%, I have to wait for that to go away. If this was less than 33%, then the threshold number would just be 2 times T. So you can see the more rain falls in the summer, the higher the TH number is going to be. The drier it is, the higher the TH number, or the potentially drier, right? Because this is just temperature, which tells you how much evaporation you could expect. So 95%, we know which one to use, 2T plus 28. So TH equals 2T plus 28. Threshold equals 2 times 28.4. That's the average annual temperature plus 28. So our TH number is 84.8. That's step 1 of step 1. We got our TH number. So step 2, you have to determine is a humid, desert, or steppe climate. And if P is greater than TH, so in this case, P is going to be 74, TH is 84.8. It's a dry climate. If it's between 0.5 and 1, it's a steppe. And if it's less than 0.5, it's a desert climate. So P is 74.3. So P divided by TH, 74.3 divided by 84. In fact, just looking at it, you know it's going to be some sort of dry climate. And the reason I say that is because you can look at it and go, well, precip is 74, TH is 84, 74 is less than 84, so it's got to be some sort of dry climate. 74 is, it's in the range that we know. Just looking at that, I could tell you, oh yeah, it's more than half but less than 1. And in fact, 87. So the P divided by TH is going to be 0.87, so we know that it is a steppe climate. P divided by TH is between 1 and 0.5, 0.87, so it's a steppe climate. That takes care of step 1 and step 2. Now we know it's a steppe climate. It's some sort of BS climate. We have to determine, is it a hot or cold climate? The average annual temperature is 28. That's greater than 18, so it's a hot. So it's a BSH is the symbol. Hot steppe climate is the name. And that's it for this pre-lab video. I thought about doing more examples, but then I thought there's no point because every time you do it, it's going to be exactly the same. You just have to go through the steps of determining which 6-month period is the summer, add up the rainfall of the summer months, divide the summer rain by the annual total rainfall to determine the TH, what the TH number is going to be, calculate the TH, compare the TH to precip. So you could do that again. In fact, I'll post a link to some more practice problems that you can go through before you do the quiz if you want to try some problems on your own. That's the best way to do it, is just to go through it and do it again and again and again. And like I said, I'll post some practice problems for you to do before you start in on the lab so you can get the hang of it. If you have questions, I hope you show up at Zoom, or you can send me an email, or you can send me a text, or you can just call me anytime. Give me a call. Hey, I'm having difficulties. Do you have a few minutes to go over this? Great, let's do it. I hope you enjoy this lab. Once you get the hang of it, it's just going to be some math, and it's really, what do we got? Division, multiplication, and a little addition. Not too difficult. Good luck. I hope you enjoy it.